let's take a look at graphing linear functions. I think this is review material, so I'll try to move through it quickly. Graphing linear functions. What we get with a graph is a pictorial representation of all the solutions to the equation, the values of x and y that make the equation true. So one way to make a graph is to make a table of values. Pick values for x, solve for y, plot the points, join them with a straight line. And of course, we'll need at least 2 pairs of points to draw a straight line. If the equation's in slope-intercept form, the y equals mx plus b, or y equals ax plus b. We locate the y-intercept, the b value, and then starting at that b value, count off the slope being the rise over the run, and then we can locate 1 or 2 more points, and again join them with a straight line. If the equation's in standard form, this is the one you're probably least familiar with, ax plus by equals c. Simplest way to graph is to locate the x-intercept, and we do that by letting y be 0 and solving for x. Then locate the y-intercept by letting x equal 0 and solving for y. Plot those 2 points and join them with a line. So let's look at a couple examples. So by table of values, we've got a couple simple equations here. We can make a table of values if x is 0, always my favorite point to find. Negative 1/2 times 0 is 0. If x is, say, 2, negative 1/2 times a 2 would be negative 1. And I can plot those 2 points, 0, 0, 2, negative 1. And I'm not very good at drawing straight lines. Something like that. That would be our first line. On the second line here, taking the other function, again letting x be 0, negative 1/2 times 0 is 0, plus 3 would be 3. Letting x be 2, negative 1/2 times 2 again is negative 1, but negative 1 added to 3 would be 2. And then we can plot those 2 points, 0, 3 would be here, 2, 2 would be here. And again, I'll try to draw a straight line. And what we get in this particular case are 2 parallel lines, because they both have the same slope. The first line, the slope is negative 1/2, and the second line, the slope is also negative 1/2. We'll talk some more about that soon. Okay, so a couple more examples here. If we're in slope-intercept form, y equals negative x plus 6. 6 would be the y-intercept. So we locate on the y-axis 6. 1, 2, 3, 4, 5, 6. And then the slope is negative 1. So if the slope is negative 1, that's negative 1 over 1. So we've got a rise of negative 1 and a run, a positive 1. So we're going down 1 over 1, down 1 over 1, down 1 over 1, etc. Then we get our slope of negative 1. And then for y equals 3x subtract 1, this one our y-intercept is negative 1, so we locate negative 1 on the y-axis, and our slope is 3 over 4, so we're going to rise 3 from there, up 1, 2, 3, and over 1, 2, 3, 4, and then up 1, 2, 3, over 1, 2, 3, 4, and draw a line through there. The point of intersection is where the 2 lines cross, and it looks like they're crossing at 1, 2, 3, x is 4, and y is 2. And the interesting thing about that particular point is it's a solution to both equations. Remember, the graph of a function shows all the pairs of values that make the equation true. So if you take the first equation here, if y is 2 and x is 4, we get 2 equals negative 4 plus 6 is 2. That's true. And then taking the second equation, if y is 2, 3/4 times x, subtract 1, 3/4 times 4 is 3, and 3 subtract 1 is 2. So again, it's the value of x and y that makes both the equations true. That's what happens at the point of intersection. And then graphing by intercepts, this is a new one for most of you. Essentially what we're doing is finding 2 points, but the 2 particular points we're finding are the intercepts. So if I let x equals 0 and solve for y, I get negative 3y equals negative 6. Divide both sides by negative 3, and I get y equals 2. So when x is 0, y is 2, and that's going to be my y-intercept, this point on the graph. And then if I let y be 0, I get x equals 6. 1, 2, 3, 4, 5, 6. I now have 2 points, and I only need 2 points in order to graph a linear function. So that's pretty quick to do. If we wanted to rewrite it in slope-intercept form, we should get the same result. More room here. So if I take the same equation, x subtract 3y equals negative 6. Oops. And put it in slope-intercept form. To do that, I need to solve for y. So I can subtract x from both sides. So negative 3y equals negative x subtract 6. And there. Let's put that over there. And then I can divide by negative 3. That'll give me y equals, let's see, a positive 1/3 x, negative divided by negative plus 2. So that gives me a slope of 1/3 and a y-intercept of 2. And then going back to our graph, the y-intercept is 2, and the slope is down 1 over 3. Down 1 over 3. It's the same graph. Okay, a couple special cases, vertical and horizontal lines. So if we have x equals c and y equals c, they're both linear equations, but only y equals c is actually going to be a linear function. So if we graph x equal a constant, that means for any value of x, the x-coordinate is always equal to that particular constant. So the graph of x equals c is a vertical line, so it fails the vertical line test for a function. And the slope of a vertical line, x equals c, is what we call undefined. Whereas for a horizontal line, y equals c, the slope is 0. A rise of 0 and a run of whatever. It doesn't increase, it doesn't decrease, and the graphs look like this. When we're looking at graphs of functions, whether they're linear or nonlinear, try to always look at them from left to right, just like you're reading a book. If the graph is moving upwards, it's what we're calling an increasing function. And if it's a linear function, it's going to have a positive slope. If the graph's moving downwards, as we're looking at it from left to right, it's what we call a decreasing function. And it has a negative slope. Oops. There we go, slope. So linear functions always have a constant, consistent slope. Nonlinear functions have slopes that change as you move from left to right. That's one of the things that you spend a lot of time studying in calculus, is slopes of nonlinear functions. Linear functions aren't that complicated. We can just look at the equation to tell what the slopes are. Okay, given 2 points, how do we find the slope between them? I think you probably remember this particular formula. What we've got with the slope of a line, it's the change in y over the change in x, because it's a rise over our run. There is a second version. You can also get the same result by doing y1 subtract y2 over x1 subtract x2. Just be consistent. when you're looking at 2 points. Oh, excuse me, made a mistake there. And let's clean that up over here. Y2 subtract Y1 over X2 subtract X1, I think is a version that most of us have seen the most. We get the exact same result if we do Y1 subtract Y2 over X1 subtract X2. We just have to be consistent in the order that we're using our intercepts. Don't mix them up and do something like Y2 subtract Y1 over X1 subtract X2. If you do that, the slope's going to have the wrong sign. Okay, so given 2 points, find the slope. If you want, you might find it helpful to label these x1, y1, x2, y2, and then our slope will be 4 subtract negative 1 over negative 2 subtract 1. So y is on top, x is on the bottom. Be careful with your signs. It's easy when you're subtracting negative numbers to accidentally leave a sign off there. So this will give us 4 plus 1, or 5 in the numerator. Negative 2 subtract 1, or negative 2 plus negative 1 will give us negative 3 in the denominator. So our slope is 5 over negative 3. And easy to do a quick sketch, just double check. So locating our first point, 1, negative 1. Our second point, negative 2, positive 4, would be about there. So that would be our line. And looking at it, does it look like, first of all, that it has a negative slope? It is decreasing as we go from left to right, so it makes sense it has a negative slope. And we're going down 5 over 3. So easy to double check it, your calculations visually. Okay, getting back to parallel and perpendicular lines. Geometrically, 2 parallel lines lie alongside each other. They do not get closer or further away from each other. And it's pretty intuitive. So 2 parallel lines, same slope. Perpendicular lines will intersect at 90 degrees, or what we call a right angle. And so if we have one line here, a perpendicular line, so that the angle between the 2 lines is 90 degrees. So with perpendicular lines, generally one line has a positive slope, and the perpendicular slope is going to be negative. Again, algebraically, 2 parallel lines will have the same slope. So the slope of one will equal the slope of the other, whereas perpendicular lines have slopes that are what we call negative reciprocals of each other. And didn't write that very nicely there, did I? Didn't do much better. Okay, well, let me illustrate that. 2 perpendicular lines, the slopes are negative reciprocals. Means that if you take one of them, the slope of the other is the negative of 1 over the first slope. So a few examples usually makes this clear. If one of the lines has a slope of 2, the perpendicular slope will be negative 1/2. If one of the lines has a slope of 3/2, the perpendicular slope would be negative 2 over 3. So flip it over and change the sign, and then you'll get 2 perpendicular slopes. Okay, so these 2 lines, this one has a slope of negative 1/2, and this one has a slope of negative 1/2. So these 2 lines are going to be parallel. This one, the slope is 3 over 2, and this one, the slope is negative 2 over 3. These 2 lines are going to be perpendicular. These 2 lines, one has a slope of 2, the other has a slope of negative 2, are going to be neither parallel nor perpendicular.